Hello everyone, my name is Tabo Protobakuli and welcome to the demonstration of the major milestone of my project. It's a prototype, of course. The full project is called the VNC Threat Mitigation and Autonomous Cyber Defense Framework. So what are the cyber defense framework? That is the DDoS attack, denial of services. Okay. Now what are our ultimate goal is to build an intelligent system that can proactively identify complex threats like data exfiltration over VNC and autonomously respond to the network attack like DDoS. So it's normally about the DDoS files, and of course we are just trying to test in the VNC till the time we are using a simulation data type with the machine learning that we have developed, rather the self healing systems. Okay, now what are the ambitious goal is to provide the best entire framework that I will prove to the core. Okay, now let's see, this is the you can see this DDoS detection thing, right? This one. So this is the file that we are providing now. Yeah, hold up a second. This is the thing that we are doing actually. So what we are gonna do is actually show what are the DDoS, rather the traffic attacks we have analyzed. This is the CSV file that we have generated from the cleaning and the pre-processing of the ML languages. Just to hold up a second, let me show you. Yeah, this one. This is the normal data packages, or rather the package that we have analyzed with the ports. Actually, you can see this is the we have used the Friday working afternoon thing, CSV. The data set is always available. Let me tell you this. Okay, we have done from the CCIC file. So you can see the flow ID with the source IP, source port, destination IP, destination port, protocol, timestamp, flow duration, and the total and the packets which are being sent to the files. So exactly that we are doing. You can see the whole thing that we have sent. Anyways, this is the Friday. This is to analyze the normal traffic and the sophisticated DDoS attack. The previous attacks. It is from the 2019. We will probably add more of the attacks from the public data sets that have been leaked by the both the governments and the normal public companies, that you can say the multinational companies. So yeah, of course what we are using, let me show you. This is the requirements.txt, the pip that we're using pandas, numpy, scikit-learn for the machine learning training. Okay, requests, we are actually requesting from the all the sites to maintain, and of course the analyzation from the matplotlib. These are the things we are using, the panda data set to analyze the things, right? So yeah, now what we are doing is we are preparing the data. With step 1, we are taking the massive raw CSV files and we are preparing our for model. Normally we clean it, handle missing values, and select the most important features, right? The logs here you can see what you can happening. Okay, now what, see, we are preparing data. Hold up a second, let me show you the main thing, right? Just hold up a second. This is the main.py that we are using. It will take a bit, as because it loads all those data sets into a one single module for a easy learning. Okay, yep, it has been there. This is the real-time simulation data that we are using, using the Tkinter thing. So this is the NTRO prototype, cybersecurity ML prototype, you can see through, right? So yeah, so we can run the data from here, we can train the model from here and start the real time. It's step 1, it's step 2, and it's step 3. It's a simple basic process. What we are going to think, or rather to add in these things, is we may possibly add a few more steps aside from this. Okay, just hold up a second. Yep, what we can do is we can first of all, what we do is that we are just doing for the DDoS attacks. Now for Trojan and mass malware attacks, we can put these things into this. It's simple, it's not too difficult, right? Another thing that we can do is the ransomware. Most of the things are being attacked into the VNC servers, through normally yeah, let me just put this away so that you can see through, right? Yeah, I guess so, you can see, right? So these VNC, or rather these things are being attacked with the ransomware. Now these always hold a server. Okay, of course it's a virtual network servers, but these servers actually run in some operating systems, mostly Linux. It uses Linux servers, and mostly the most biggest government sectors are being run for a secure protocol, that is Red Hat. Mostly Red Hat. Yeah, Red Hat is a corporate and the best secured Linux distro that you can see. It uses the DNF repo. Yeah, of course, it is what it is. Anyways, so aside from this, just hold up a sec. Aside from this, what we can do is we can add these things into this one single thing. Another thing that we can do is mostly it will help a lot to the users to actually maintain stuffs, that is, we are gonna add the best thing, that is the public data set easy handler. Yeah, exactly, that we are gonna use. Means all those data sets that we are using over here, if you can see through. Okay, just hold up a second. This is Tkinter that you are using actually. Yeah, what we can do is, this is the data sets where we are using data sets for the paper DDoS, that is the 2019 attacks. Now for instance, if you want to add 2023, 24, or latest 25, if some things got leaked, and the all 10 years back to back notes, then we can put into this whole system repo. That's the biggest thing that we can get. So anyways, aside from this, these are the most future implementation that I'm saying right now, as because for the easy and the fastest way to analyze DDoS reports. That is why we are using this ML simulator, right? To ease the way of the DDoS attacks and the exfiltration attacks that have been there in the VNCs. So this is a futuristic things to secure most of the future files in the operating systems and the systems. Of course, this is totally based on the cybersecurity systems. Anyways, so let's start. We will prepare the datas, and it works on the exfil data CSV. That's this CSV file, if you can see through. Hold up a second, let me show you. This is the exfil data.csv. Exact. And another we are doing that, this is a DDoS combined, and it's a 4.485 gigs of data sets that we are using currently. If we have the best power in the future time, if we have the best power and the computational capabilities, we can extend up to how much? 1 terabytes to 8 petabyte. This is the analysis at least of multi global data sets. How interesting is this? So anyways, let's show you. I won't show the .py or dot things that we are using, but you can see this is the we are gonna show this thing, you know. So yeah, we did the process of the xfield data, you can see over here. Now let's train the model, right? Let's train the model. The train sets will be splitting and it will clean up. Yeah, of course my computer is gonna lag as because it helps to, you know, show this. Let me make this screen big, you know, it will be quite easier to show. Yeah, you can see this is the model performance with the real-time simulation. I have not shown the real-time simulation, I have to start it from here. So yeah, this is the confusion matrix that we are using, and to ease up things I'm gonna say this is the number of DDoS protocols that that have been made. Of course, it will be easier to show using this pen, you know. Anyways, so this shows the number of packets that have been sent in the DDoS denial service in the simulation OS from the public datasets that we have trained. You can see this one. So anyways, and this part is the predicted of DDoS. You can see this is the benign part, predicted label with the true label, but this is the main file. We are actually performing this. You can see this through. Hold up a second. Yeah, this one, and this is the benign, means this portion and this portion, this matrix is as a benign, means there is no, this is a fake packets, this doesn't consist of overloading of the DDoS. This is the main thing. This is the predicted level that the benign is happening, but actually the benign is not having the DDoSing happening. The 16 loss sets are there, but according to the whole confusion matrix thing, if you say the predicted things is, if you sum this, if you add up, so let it be something of x. Just think about this, right? Let this be x. Now this 16 is too much lesser than x, but this thing is quite comparable to x, so we can analyze 38,000 of DDoS to this x. So how interesting is this? And this is, of course, this is nothing, and this is the computer thinks that this is a DDoS, but this is not a DDoS, of course. So it's too much interesting, and let us simulate the process, you know. Of course we have the time logs. I'm currently working, I just finished it for the past 5 days. Now this is 12 o'clock right now at night, midnight. I'm showing you, this is the real-time simulation. You can see this shows the DDoS confidence is high. Most of the packets has been lost, however few can be also DDoS, few can't be, but you have seen that x that was approximately to 100k requests. Out of 100k requests, only 16 were proper DDoS. 36,000 approx were not DDoS. However, 38,000 were DDoS, and it was predicted by the thing and got secured. So this is what it is, and the prediction level of 16 by 1k is approximately point something percent, and it's very negligible to know the vulnerabilities of the actual OS. How interesting is this? This is our project. And yes, to conclude, what we can say is we have successfully built a working prototype that takes the raw network data, trains a highly accurate machine learning model, and uses that model to detect threats in a live simulation that we have doing this right now. This proves the core principle of our autonomous cyber defense framework in sound and achievable. This is the foundational first step, of course, and I'm excited to build upon it. And my team, I'm very happy to work on my team and do the best for the service of our nation. Of course, it is for the security of our country and of organizations that are that consist of very sensitive public data. So I hope that it really, helps to the mitigation of the people and secure the private data. Thanks for watching.